Hello students, welcome to the solutions of the partial flow diagram MCQ practice paper. 15 MCQs plus 2 numericals. I will walk you through every answer with the why behind it. Take out your attempt sheet, keep it next to you and let us begin. Question 1. The correct answer is C. Sewers run partially full for 3 main reasons. The air space above the flow provides ventilation for methane and hydrogen sulfide, allows headroom for peak flow variation during the day, and prevents surcharge when heavy flow arrives. Cost, capacity, and ease of cleaning are not the primary drivers. Question 2. The correct answer is B, 0.81. In the partial flow diagram, velocity peaks when the hydraulic radius r over r full reaches its maximum. Analytically, this occurs at d over d equal to 0.81 and at this depth, v over v equals 1.14. Question 3. The correct answer is C, 0.94. Discharge is the product of area and velocity. It reaches its maximum at d over d equal to 0.94, where q over q equals 1.07. Beyond 0.94, area increases very slowly while velocity drops, so total discharge falls. Question 4. The correct answer is C, 1.14. The maximum velocity ratio V over V in the partial flow diagram of a circular sewer is approximately 1.14. This occurs at d over d equal to 0.81. Remember this pair 0.81 and 1.14. Question 5. The correct answer is dr equals d over 4. For a full circular pipe, area equals pi d squared over 4 and wetted perimeter equals pi d. Their ratio simplifies elegantly to d over 4. Remember this hydraulic radius equals quarter of the diameter for a full circular. Question 6. The correct answer is A. Hydraulic radius is defined as cross-sectional area of flow divided by wetted perimeter. R equals A over P. This is the fundamental definition and applies to any channel shape, circular, rectangular, trapezoidal, or partly full pipes. Question 7. The correct answer is B. Manning's formula for velocity of flow is V equals 1 over n times r to the power 2/3 times s to the power 1/2. Remember the exponents 2/3 on hydraulic radius, 1/2 on slope. This is the most common formula for gravity sewer design. Question 8. The correct answer is B. Chezy's formula is V equals C times square root of Rs. It is the older, simpler form of the open channel velocity equation. Manning's formula is a modification of Chezy where the coefficient C absorbs the dependence on hydraulic radius. Question 9. The correct answer is B. The relation between Chezy's coefficient C and Manning's roughness N is C equals 1 over n times r to the 1/6. Notice that C depends on r while n is a constant depending only on pipe material. That is why Manning's formula is more practical for design. Question 10. The correct answer is B. D over 4, the same as a full pipe. This is a beautiful surprise. When the pipe is half full, both the wetted area and the wetted perimeter reduce by exactly half. Their ratio, which is the hydraulic radius, remains unchanged, so half full pipe and full pipe have the same R. Question 11. The correct answer is B, 0.60 meters per second. This is the CPHEEO minimum self-cleansing velocity for sanitary sewers. Below this velocity, suspended solids like silt and grit start to settle inside the pipe, causing blockages. Remember this number asked in every GATE and EC exam. Question 12. The correct answer is B, 1 in 500. Slope S equals fall of bed divided by length. Substitute 1.5 over 750 equals 0.002, which is 1 over 500 or 1 in 500. Question 13. The correct answer is B, 0.013. This is the typical Manning's roughness coefficient for stoneware or reinforced concrete sewer pipes in good condition. Rougher old brick sewers can go up to 0.015 or higher. Very smooth PVC or HDPE pipes are lower at 0.010. Question 14. The correct answer is B, P over P, the wetted perimeter ratio. Wetted perimeter equals theta times R and full perimeter equals 2 pi R. Their ratio is theta divided by 2 pi, perfectly linear in the central angle theta. All the other ratios have trigonometric terms and are non-linear. Question 15. The correct answer is B. Manning's formula is a modified form of Chezy's, with Chezy's coefficient C expressed as 1 over n times r to the 1/6. In other words, Manning has absorbed the variation of Chezy's C with hydraulic radius into a fixed roughness coefficient n, which depends only on pipe material. Numerical 16. Given D equals 0.5 meters, S equals 1 in 800, which is 0.00125, N equals 0.013, pipe flowing full. Step 1. Hydraulic radius R equals D over 4 equals 0.125 meters. Step 2. Velocity by Manning's formula. V equals 1 over 0.013 times 0.125 to the power 2/3 times 0.00125 to the power 1/2. Now 0.125 to the power 2/3 equals 0.250. 0.00125 to the power 1/2 equals 0.0353. So V equals 76.92 times 0.250 times 0.0353, which equals 0.68 meters per second. Step 3. Area equals pi times 0.5 square divided by 4 equals 0.1963 square meters. Step 4. Discharge Q equals AV equals 0.1963 times 0.688 equals 0.133 cubic meters per second, or 133.5 liters per second. Numerical 17. Given R equals 0.10 meters, S equals 1 in 625, which is 0.0016, C equals 60, area 0.0707 square meters. Step 1. Velocity by Chezy's formula. V equals C times square root of RS equals 60 times square root of 0.10 times 0.0016 equals 60 times square root of 0.00016 equals 60 times 0.01265 equals 0.759 meters per second. Rounded, V is approximately 0.76 meters per second. Step 2. Discharge equals area times velocity equals 0.0707 times 0.759 equals 0.0537 cubic meters per second, or 53.7 liters per second. Step 3. Self-cleansing check. V equals 0.76 is greater than the minimum 0.60 for sanitary sewers. So the design is self-cleansing and acceptable. That is all, 17 questions. Total the marks on your scorecard. Section A out of 15, Section B out of 10, total out of 25. If you scored 22 or above, excellent, you're exam ready. 17 to 21, solid. Revise the numbers you missed below 17. Please rewatch the concept lectures before your next attempt. Thank you for studying with Learn Civil Easy.